All right, section 6.6, special products of binomials. So here we're going to be multiplying binomials, and specifically just binomials. But these binomials have some special qualities to them. However, if you are not seeing the pattern that belongs to these special binomials in multiplying them, don't worry. It actually just takes practice at recognizing them. What you can do is just multiply like we learned in the last video. Just multiply by either distributing or stacking or the box method. You're just going to do that, okay? If you're so don't panic if you don't see the specialness of certain binomials. It comes with time. So we're going to multiply binomials using the FOIL method. Remember, I don't like to say FOIL, but it's still out there. But the first terms, the outside terms, the inside terms, and the last terms. We're going to multiply binomials, finding products that are the difference of squares. We're going to square binomials, finding products that are perfect square trinomials. And then we're going to identify the differences of two squares and perfect square trinomials. And we'll see what we mean by those. So if we're going to follow the FOIL method, and we are going to review it just because it's something you once learned and maybe it's the best method for you. And so the first one says the first times those are those two. Those would be considered the first. That stands for F. The outside ones are the furthest ones from the left and the right. Those would be your outside terms. Obviously, your inside terms would be the 1 and the 4x. And then finally, your last terms in those binomials would be the 1 and the 3. That's where FOIL comes from. First, outside, inside, last. But if you notice, it's just distribution. And so they do that. The first, the last, and you notice that the inside and the outside terms will combine together. They always combine together if we're doing binomials of standard form, okay? So 6x and 4x would count to combine together and we would get that. So that is one way of doing it. You still can use the box method. You can use the stacked method. You can distribute however you like to do it. We're just reminding you of FOIL. In this case, first would be x times x, that's x squared. The seconds would be, or outside would be x times a negative 6. The insides would be 6 times x, and the last would be 6 times a negative 6. And then you'll notice that the inside terms fall out. They become 0. And this is what I mean by special terms, and you'll start to get used to them. Notice that this and this are exactly the same, and this are exactly the same. And the only difference is the sign in between. So when they have opposite signs, what happens is these middle terms cancel each other out, and we're just left with the first term squared, x squared, and the last term squared, 36. So it's just instead of FOIL, it's just F and L. Okay, first and last. All right, so this is what we call the difference of two squares. When you have two parentheses or two binomials that look almost identical with the exception of their sign in the middle, then they will multiply out by just squaring the first term and squaring the last term and putting a subtraction sign in the middle. It will always be subtraction. So this is the pattern that we're trying to learn to see. If you don't see it, it's okay. Just FOIL or distribute or stack or put it in the box. Now, just to remind us, what are perfect squares? Well, 1, 4, 9, 16, and so forth. We've given you up to 400. That would be 20 times 20. There are other numbers that are higher that you can find, but for right now, I think 1 through 400 is good. So if you see any of these particular numbers at the end of your problem, or you'll know that that's what it multiplies to. So let's look here. I noticed that these binomials are very similar except for their signs in the middle. So I don't even need to do FOIL. I just need to square the first term, which is x squared, and the last term, which is 25, and put a minus in between, and I am done. However, just so you can see, if I took this x plus 5 and x minus 5, x times x is x squared. X times 5 is 5x. Negative 5 times x is a negative 5x. And negative 5 times 5 is negative 25. These middle terms, the same term, but they're opposites of each other. They'll just cancel out to 0, and I'm left with x squared minus 25. So I can recognize quickly, and I've done that because I've had lots of practice doing it, that it's just really x squared minus 25, or I can even box it or FOIL it or stack it. Okay, I noticed on B, these terms are almost identical except for the middle. So I'm going to square the first term. 8x times 8x is 64x squared. And square the last one. 3 and negative 3, that's 9. And that's my answer right there. Notice how I squared the first term and squared the last term. Same thing here. I've got the same thing going on. They're identical except for their signs. So I'll square the first term and I'll square the last term. And that gives me x to the 6th minus 4. Okay, now we're moving on. Now we're going to do it when they're exactly the same. Now, this is where I want to use extreme caution. I have students, and we have students all the way up, even forgetting in calculus what they should not do. So when you see something like this, x plus a squared, it does not, no, never does, will never be, absolutely not, please don't do it, write x squared plus a squared. This does not go here and this here because there is a plus sign in between them. And because there is that plus sign in between them, I cannot follow. That rule will not apply. What it does mean is that it means I have x plus a twice. And you can see that here. So the next time you want to do x squared plus a squared after having seen this, just remember my rant. It does not, no, never will, absolutely not. Don't do it, don't do it, don't do it. Don't do that. Yeah, it means this. And that means then that we're going to have to distribute and FOIL. And what it actually means is the first term squared. If you take the first and the last and multiply them together and then times by 2, you get the middle term. The first and the last, that's the ax, and times by 2, that's the middle term. And then just square the last term. Notice there is a middle. In this one, there was not a middle. If you get something like this and there's not a middle, you know you've done something wrong, okay? You must have a middle. The only time you don't have a middle is when it is something like, get there, this, where their signs are opposite. But when you have something like this, and their signs are the same, whether it's minus or in this case, back plus, it doesn't matter. There will always be a middle portion. Please do not try to jump away from it. You've got to multiply it out and get that middle portion. Okay, and here it is for subtraction. What will happen is the first term is squared. The middle term is just x times a and times it by 2, but put a negative. And then the last term is always going to be a plus again, plus a squared. So here's what I have. Now, if I were taking the test and I did this, what should you be screaming right now? No, never, don't do it, Mrs. Stubbs, stop, don't do it, that's wrong. Okay. Hopefully, like, you'll be traumatized every time you think of doing that and you'll do it right. What that really means is 2x plus 3 times another 2x plus 3. And now I know that these are perfect square trinomials, so 2x times 2x is 4x squared. 2x times 3 is plus 6x, and 3 times 2x is plus another 6x, And 3 times 3 is plus 9. And my middle terms, that's just doubled, so I have 4x squared plus 12x plus 9. Now remember, we said you square the first term. That's the 4x squared. You take 2x and times it by 3, that gives you 6x. And then you times it by 2. Well, what's 6 times 2? 12x. And then you square the last one. 3 squared is 9. Do I have a middle term? Absolutely. It will make a trinomial. It does not become a binomial. It is a trinomial. And there you have it. There's your answer. So here we have this one. What does that really mean? It really means 5x minus 1 times 5x minus 1. And I am going to have a middle term, aren't I? The first term will be those two multiplied by each other, or 25x squared. The middle term is going to be 2 times 5x times 1. 5x times 1 is 5x, so it's just going to be 5x. And the end term is going to be negative 1 times a negative 1 plus 1. So I really get 25x squared minus 10x plus 1. If we were to have done this in the traditional box method, which you can. Five x times 5x is 25x squared. 5x times a negative 1 is a negative 5x. Negative 1 times 5x is a negative 5x. Negative 1 times a negative 1, positive 1. Here's my like terms. They can be added together to give me 20. So I start with my first term, 25x squared minus 10x plus 1. And they are identical, aren't they? Either way is fine with me. I don't care if you can recognize the pattern or not. You'll get there. All right, here's another one. Now notice that the constants first and the variables second. Is that okay? Absolutely. It's totally okay. That just really means 9 minus x. And I really would like for you to write it this way for the first little while so that you don't make that fatal mistake where I have to say, no, never, don't do it, don't do it. Okay? So 9 times 9, 81. Minus 2 times 9 times x minus a negative times a negative is plus x squared. I end up with 81 minus 18x plus x squared. That would be the answer. Here's another one. Y to the third plus 1, which does it really mean? It really means y to the third plus 1 times y to the third plus 1. And y to the third times y to the third is y to the sixth, right? And y to the third times 1 is y to the third. We're going to double that. So that's 2y to the third. And 1 times 1 is 1. That should be our answer. And you could check it in the box if you weren't sure how we got there. Oh, look, here's my rant. No, never, don't do it, don't do it, don't do it. Right here, right? Because there's a plus sign in there, had it been x times a or x times a to the second, then you could have said x squared, a squared. But because there's a plus sign or a minus sign, it doesn't matter which, because we have a subtraction or addition between it, we can never, ever, don't do it, scream, run away, don't do it that way. It must be done like this. Remember, that means x plus 6 times x plus 6. All right, so here we have some opportunities to do it. I'm looking at this first one. I notice they're almost identical, except for one has a plus, one has a minus. So that's just going to be x squared minus, what's 10 times 10? 100. Okay, and let's go over here. This is this one is one of those special ones where it really means x plus 3 times x plus 3. And that's going to be x squared. What's x times 3? That's 3x, and double it plus 6x. And then 9 squared is plus 9. Remember, it's always going to have a middle. Same thing here. 2x, if we square this, we're going to get 4x squared. What's 2x times 5? Well, that's 10x. We're going to double it. That's going to make it a minus 20x. And a negative 5 times a negative 5 is plus 25. Come over here for 3. 2x times x is 2x squared. 2x times 3, I'm going to do distribution here. Negative 1 times x is minus x. And negative 1 times 3 is minus 3. Here's my like terms. Combine those. I get 2x squared. Let's see, plus 5x minus 3. And over here, x squared times x squared is x to the 4th. X squared times a negative 3 is a negative 3x squared. 4x times x squared is plus 4x squared. And 4 times a negative 3 is minus 12. Here's my like terms. So I have x to the 4th minus x squared minus 12. And that would be my final solution there. All right, so I want you to practice this. You will actually have, just take an opportunity, if you can, find other ones that you can practice and do. Go online and say, give me binomials to times together or something, multiplying binomials. And you can go to Khan Academy. They're going to give you stuff. That should be a link that you could get to. So just get some practice doing this. All right. Have a good day and enjoy your homework, because we should always enjoy doing a little bit of math. Bye-bye.